We've always wondered about life out there, but what if we told you that the possibility of more life forms has become surer than ever? It's so powerful it might have just shattered our understanding of the universe. We've all heard about how the new James Webb telescope is kind of like a time machine because it can look back to the early formation of the universe. 6 shocking galaxies have been discovered that defy all explanations. The James Webb telescope has identified 6 galaxies that exist 500 million years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. Join us as we discuss Michio Kaku breaking his silence on the James Webb telescope's clearest image in history, the shocking discovery. Building a galaxy is no easy feat. It took the universe over 350 million years to finally form the very first galaxies. They were pretty small and took their sweet time to become the galaxies we know today. But get this, scientists have just discovered 6 ancient galaxies that are breaking all the rules. These galaxies are thought to have formed just 500 million years after the Big Bang, yet they contain populations of tens or even hundreds of billions of stars. American theoretical physicist Michio Kaku is just as puzzled by this groundbreaking discovery that could change everything we know about the universe. The James Webb Space Telescope, a $10 billion project launched by NASA in December 2021, spotted 6 colossal galaxies that are each roughly the same size as our very own Milky Way. These galaxies were formed way too early in the history of our universe. The mass of stars within some cosmic objects is not just a few times larger than our Sun, but several billion times larger. And if that's not enough to make your jaw drop, get this, one of these objects could have a mass of stars up to a whopping 100 billion times larger than our Sun. To put it into perspective, the Milky Way, home to our beloved Sun, has a mass of stars that's a mere 60 billion times that of our Sun. This discovery is truly mind-boggling, and as Erica Nelson, one of the scientists who worked on this project, put it, it's bananas. Echoing her sentiments, Michio believes that huge gaps in our knowledge are about to be addressed with these new findings. This latest discovery feels like a puzzle piece you don't know where to fit. The team of astronomers who spotted these galaxies has dubbed them universe breakers, because if they are indeed real, our entire understanding of galaxy formation will need to be revisited. This discovery could call into question some of the basic rules of cosmology. So, get ready for some exciting new revelations about the cosmos. Have you ever wondered how the universe, which was once a minuscule fraction of an inch across, expanded to its colossal size today? The widely accepted Big Bang model tells us that the universe was born as a blazingly hot and dense point over 13.7 billion years ago. But what happened next to shape the universe into what it is now? Imagine the universe as a baby born from a single point and expanding at an incredible rate during its first growth spurt, doubling in size over 90 times. As it grew, matter formed and the universe cooled. Then the universe experienced a magical moment called recombination, where electrons combined with nuclei to form atoms and the universe became transparent. Then the Dark Ages followed, a period of darkness before stars and galaxies emerged. Interestingly, 150 to 400 million years later, the cosmos started to come out of this darkness in a period known as reionization. Fast forward 9 billion years after the Big Bang and our solar system sprang to life. Except these new galaxies appear to be roughly 13.5 billion years old. This means they began forming somewhere around the Dark Ages. The galaxies are so large that they conflict with 99.9% of cosmological models that scientists curated with a lot of hard work. This indicates that either the models will need to be changed or the scientific theory of galaxy formation needs to be completely re-evaluated. The discovery of such large galaxies so soon after the Big Bang raises the possibility that the Dark Ages weren't all that dark after all and that star formation began far sooner than previously believed. Thanks to the hard work of scientists, we now know that the Dark Ages lasted from about 380,000 to 150 million years after the Big Bang and that the first stars began to form around 180 million years after the Big Bang, marking the end of the Dark Ages. But for the universe to exist as it does today, hundreds of thousands of new stars would need to be created each year by these new galaxies. But there's not much at stake except our entire understanding of this wonderfully complex cosmos we call home. Before this discovery, the farthest distant galaxy ever discovered by Hubble was GN-Z11, but we'll circle back to that in a minute and break down its features for you too. For now, Webb's discoveries could fundamentally change our understanding of cosmology and challenge everything we ever knew. Maybe more studies on the Milky Way already hinted at how soon stars came into being after the Big Bang. Maybe the discoveries of these galaxies were just a matter of time. This discovery is bound to surprise you. Scientists have just revealed the precise age of our very own galaxy, the Milky Way, and the results are shocking. According to a new study published in the prestigious journal Nature, some parts of the Milky Way formed just 800 million years after the Big Bang. Astronomers used a survey of almost 250,000 stars to clock the development of the Milky Way, splitting the spiral disk into two populations, the younger inner disk, of which our Sun is a part, and the older, thicker disk that extends further out. They discovered that the thick disk likely started forming around 13 billion years ago, just 800 million years after the Big Bang, while the intergalactic halo formed around 2 billion years later. But that's not all. Turns out the inner halo came into existence after the Milky Way merged with another dwarf galaxy, Gaia Enceladus, between 8 and 11 billion years ago. While this discovery sheds light on the formation of our galaxy, scientists wish the 6 new galaxies didn't defy all logic. Let's break down what else we know about these enigmas. Oh yeah, these galaxies are packing more heat than we ever thought possible. But that's not all. The density of matter in these galaxies is so mind-bogglingly high that it's making cosmologists break out in a cold sweat. And if that wasn't enough, the amount of normal matter in the galaxies is at odds with the amount of dark matter in their halos. It's like trying to fit a square peg in a round hole, only this peg is made of a material we don't fully understand yet. To make matters worse, the research team has been busy scouring their work for errors, but so far, the data and their interpretation of it have remained solid. The idea of rewriting all history books as we know it definitely sounds like a doozy. No wonder researchers are hoping they made a human error instead of accepting how off the mark our knowledge has been. Although the majority of these celestial objects appear to be galaxies at this time, scientists have not ruled out the possibility that some of them may actually be gigantic quasars or supermassive black holes. Except this raises more questions than answers, as the amount of mass concentrated in one place is extremely difficult to explain so early in the universe's history. If these objects are indeed supermassive black holes, it could mean that our understanding of black holes needs to be revised. Supermassive black holes are already known to exist at the centers of galaxies, but the idea that they could form so early in the universe's history challenges current theories. Now, before this new discovery blew us away, the JWST and Hubble had already discovered something older than we'd ever imagined, Glass Z13 and GN-Z11. Last year, JWST found the oldest galaxy ever seen in the universe called Glass Z13, and it dates back to a mind-boggling 300 million years after the Big Bang. That's right, we're talking about a galaxy that is over 13 billion years old. This discovery is beyond anything astronomers could have imagined, and it could rewrite the opening chapters of cosmic history as we know it. Glass Z13 is no ordinary galaxy either. Despite its age, it has a mass exceeding 1 billion suns, but it is actually smaller in size than our very own Milky Way, which is home to our solar system. The width of the Milky Way is nearly 100,000 light-years, whereas Glass Z13 is just a few thousand light-years across. But that's not all. Scientists also discovered another ancient galaxy nearby called Glass Z11, which is about the same age as the previous record holder GN-Z11. GN-Z11 was the talk of the town in 2016 when Hubble astronomers, using NASA's Hubble Space Telescope, broke the record for the farthest galaxy ever seen in the universe. GN-Z11 was 13.4 billion years ago and was formed just 400 million years after the Big Bang. GN-Z11 is 25 times smaller than the Milky Way and has only 1% of our galaxy's mass in stars, but it's growing rapidly and forming stars at a rate 20 times greater than our own galaxy. These findings provide new clues about the nature of the very early universe and give us a sneak peek into the secrets that await us. Now, the James Webb Telescope has been tasked with securing even better pictures than its predecessor, Hubble. During its first few months of operation, the powerful space telescope spotted objects in the early universe using its cutting-edge technology to study the universe in infrared. What makes this feature cool, you ask? Well, infrared is the perfect wavelength for spotting light that has traveled for billions of years to reach us, feeble and stretched out into longer wavelengths by the expansion of space-time. This broadening of the wavelength is known as redshift. But what does the word redshift mean? Well, when we observe the light from faraway galaxies, we notice that it has a slightly redder color than what was emitted long ago. In simple terms, as the light stretches out over acres and acres of space, the color of the wave shifts to red. This causes the waves to arrive at Earth with a longer, redder wavelength. But why is the wavelength changing shape and color as it moves? It's not just because the galaxy is moving away from us, as many people think. Instead, the empty space between us and the galaxy is actually expanding, pushing the galaxy further and further away. This discovery completely turned things around as we realized that galaxies aren't racing through stationary space. The faster the galaxy is moving away from us, the more redshift we observe. The higher the redshift value, the further the galaxy is from us and the more the light has stretched. Glass Z13 has a redshift of 13, and in comparison, GN-Z11 has a redshift of 11. By studying redshift, astronomers can even see back in time to the early days of the universe when the first stars emitted ultraviolet light that has since been redshifted all the way into the infrared part of the spectrum. The James Webb Space Telescope is specially designed to study these distant and earliest galaxies by using infrared cameras and spectrometers. This means that the JWST can peer further back in time than ever before, giving us a glimpse of the early universe that was previously impossible to see. But now that you understand these terms better, we've got one more latest discovery to dissect. The JWST Advanced Deep Extragalactic Survey, or JADES, has confirmed earlier distance estimates for not 1, not 2, not 3, but for galaxies. And get this, one of them has a redshift value of 13.2, meaning we are seeing the galaxy as it appeared just 320 million years after the Big Bang. This incredible breakthrough has left astronomers over the moon, with Emma Curtis Lake of the University of Hertfordshire in England exclaiming, "We've been waiting decades for this." And who can blame them? Peter Van Dockum of Yale University is even comparing the age of this galaxy to the total time sharks have existed on Earth, some 300 million years. It's simply astonishing to think that we can go from nothing to fully formed galaxies in just the blink of an eye. But as with all great discoveries, there is a catch. Not all candidate galaxies at high redshift have the same good fortune as JADES RGS Z13-0. In fact, the Finkelstein-led Cosmic Evolution Early Release Science Survey believed it had discovered a potential galaxy at a redshift of 16.4, just 240 million years after the Big Bang. But it turns out it was an imposter, discovered at a redshift of 4.9, 1.2 billion years after the Big Bang, which is still impressive, but not record-breaking. It just goes to show that in the world of astronomy, caution is key, and even the slightest mistake can lead to a completely different outcome. So, buckle up, space explorers, because who knows what incredible discoveries the future holds. But one thing is for sure, the universe never fails to amaze us. The field of high redshift galaxy studies is advancing at a breathtaking pace with the help of the powerful James Webb Space Telescope. The recent discovery of a galaxy with a redshift of 16.4, the highest ever detected, is just one example of the groundbreaking research being conducted with this cutting-edge instrument. And the excitement is far from over, as an ongoing survey called Cosmos Webb is expected to uncover even more high redshift candidates. However, some experts are concerned that the field is moving too fast, with astronomers on Twitter already scooping the open-access work of researchers who had not yet published their analysis. Nevertheless, this hasn't stopped many other astronomers from requesting additional time on the telescope or from submitting proposals for the upcoming Cycle 2 of scheduled scientific observations. Despite these tensions, astronomers are still thrilled to be gaining unprecedented insights into the early universe. Maybe galaxy formation started already at a redshift of 20, suggests Van Dockum, referring to a time just 180 million years after the Big Bang. With the JWST's ability to see even further back in time than previously thought possible, it's clear that the telescope is revealing unexpected discoveries that challenge our understanding of the universe. All in all, the race to explore the early universe and uncover its mysteries is in full swing, and the James Webb Space Telescope is leading the charge. Can there be even more groundbreaking discoveries in store? That's a wrap, folks. What about space puzzles you most? Comment below and tell us.